Good morning, everyone. Thank you for joining our conversation about robots. I'm not sure about you folks, but I'm very excited about this topic. Robots are hitting headlines all the time. They do all kinds of cool stuff like dancing, cooking, or knocking over people. But there has been this debate between humanoid robots, some also call it all-purpose robot, and purpose-built robot, which is the future and which is winning the game. So today we have two panelists join us to discuss this topic. To start the conversation, Casper, can I ask you to explain what's the difference between these two?
Yes, so humanoid robots, this is what we're all hoping for, that they're going to help us in our homes. And by definition, by design, they're compatible with the human world, right? Like they're supposed to work and be able to help us in our environments, stairs, kitchens, and all of this. And they're developing very nicely, but in reality, the robots that we've been deploying successfully for many years now are the industrial robots. So, usually single robot arms, and they had their youth in car manufacturing and electronics manufacturing. And today, companies like No Magic, we're using them for new use cases. So, for example, we're using them in logistics warehouses to automate very repetitive manual work, which is there.
Interesting. And James, I know Central AI is developing both, and which is seeing more commercial traction at the moment?
Well, humanoids haven't crossed the critical performance threshold to be useful. So we see these amazing videos out there, but the reality is designing a high degree of freedom robot to be at the performance thresholds that's safe and customers can get an ROI against. We're still 3, 5, maybe even 7 years away. However, the AI, the physical AI systems that are being developed is being developed at an incredible rate. And so off-the-shelf robots that customers have confidence in, have safety, and everyone understands the regulatory environment, you can start applying that physical AI today. And so it's really about trying to understand the continuum of purpose-built systems leading to what we call general purpose systems.
So it sounds like purpose-built robots are winning for now.
They're available now, right? So that's kind of the advantage. And we had this experience deploying robots to customers that one of the early platforms we used, the robot would break after a few months of operation, 24/6 at the customer warehouse, and it's an extreme pain, right? So the hardware has to be very reliable, because otherwise you need to somehow go to customer warehouse and repair it. This is what the traditional off-the-shelf industrial robots offer you. They have the lifespan of 10+ years, right?
Right.
With the proper maintenance.
Yeah. Do you have anything to add?
Well, so there's a ton of use cases that traditional robotics can't address today, and we call those in the industry long horizon tasks. So tasks that have all these different subtasks where a single end effector can't actually do the complete task. And so that's where the advantage of a general purpose robot comes in. But there's a significant amount of AI research that has to be developed in order to unlock that, but also on the hardware side as well.
On this, I would like to add that indeed the robot, meaning the robot arm, is one thing, but then how do we interact with the world? So the grippers, right, or end of the arm effectors, this is something that we're doing research in, and we're designing our own. And every robot that we deploy to customers, it has a tool changer, right? So it basically is able to change its hand, and we can pick from tiny items to big and heavy to boxes, and also fashion items, and even unstrapped shoeboxes where the lid is loose. We have a way of handling them inside the warehouse in a very reliable way as well.
Yeah, I want to hear more about that. Like, where are we at with purpose-built robot now? Is there certain things we're doing now that we couldn't do maybe 1 or 2 years ago?
Yeah, so I think the development in terms of a perception of what the robot sees, how it makes decisions, the development in terms of delivering speed and reliability, handling edge cases, there was really a lot of progress. And at least in our case, right, like being able to handle more of the inventory inside the warehouse has been a game changer for our customers, because they can really send everything to the robot today. And before they had to say, well, these are robot-friendly items, these are not robot-friendly items. So we need to handle them in two different ways, and that's very kind of painful to change warehouse processes to to this division.
Yeah, James, where do you see the biggest demand for purpose-built robot these days?
So, I mean, robots have been around for 50 years, and the use cases that are starting to emerge with physical AI is really around dynamic, unstructured tasks where the robot needs to be able to respond in real time in order to adapt to the variability. And so manufacturers around the world are very keen to increase the percentage of their labor force that is automated because these tools are being made available.
We have heard stories about manufacturing work is being replaced by robots. Like I know South Korea, they aim to replace 30% or increase 30% in efficiency by using robots in manufacturing. At what scale would you say now purpose-built robots are being adopted in real world?
I think it's fairly small, isn't it?
It's still tiny, right? I think our hope is to automate, millions of different tasks. And today, these industrial robots are being sold in hundreds of thousands a year. Humanoid robots are being sold in probably tens of thousands a year. So, there's still order of magnitude, but there are tens of millions of cars being sold, right? So this is really a tiny number. And I think, the whole goal is what we're working on, which is building brains for the robots, right? Some physical embodiments exist. Some new embodiments will be available and appropriately reliable sometime soon. But then how do you control this, right? So there's a lot of research and engineering, data gathering, training of the models that goes into this. It's kind of a fascinating part right now.
Yeah, so labor is one of the largest markets in the world. It's 60 trillion of capital flows from employers to employees every year. And if you think about the fraction that robots take from that, it's got to be like 0.5% or 1%. So there's a huge amount of headroom there for robots to improve and contribute to the labor force.
So would you say the technology is here already? It just we need to scale it up?
Yes and no. So I think I think about this in like a two-dimensional way, right? Like on one dimension, you need extreme reliability. So, if the robot is operating 500 times an hour, right? Like it's in some fast use case. If it's correct 99% of the time, you would think, okay, 99% is very cool. So it means it's 5 times an hour it's wrong. Every 12 minutes, something happens at the robot, right? That's not a level of service that anybody would accept, right? So you need more like 99.9, right? So that's kind of one dimension. How reliable is the robot in the use case that you have for this? And then the other dimension is diversity of use cases, like, generalization to handle more different tasks. And I think we've progressed well in reliability in narrow tasks. We've progressed well in diversification where reliability is low. So these are demos and videos that we see on the internet. But we need both, right? Like we need to somehow get to the very reliable and very scalable, the generalized behavior of the robots. And, that's where the money goes to, I think, right? Like all the investment into robotics is into this.
James, is that what you're observing or your company is working towards?
Yeah, I mean, absolutely. Generality is the holy grail, specifically manipulation. So the whole community is trying to move away from these purpose-built systems to do one-off tasks to having systems that can do multiple tasks because there's changes in the supply chain, changes in demand. But as Casper was saying, in order for that to become a reality, you need to hit the same performance and cycle time benchmarks that these purpose-built systems can in order to enable these general-purpose systems.
So how many years would you say we are away from seeing this like more common in the factories?
It depends what you're looking for. I mean, that's always a dangerous question. I mean, the trends are incredibly clear. The gains just from quarter to quarter, year to year. But it really depends on the use case. But I would say like automation in general, many of the Global 2000 are trying to rapidly adopt this new paradigm.
I think we're on an exponential curve, but it's still here, right? So, it's going to go rapidly up soon. And, we've managed to triple number of robots contracted last year and the previous year at No Magic. So if we continue the 3x couple of more times, then, the footprint will start to be very visible.
You two are, cautious about what you're saying, which is good. Let's go back to humanoid robots. And James, I know your company is developing both, and so you are still continuing the path to develop humanoid robot called Phoenix. I love the name. So you obviously see the potential, the long-term potential for it. Where do you see biggest potential?
Yeah, so what's become quite clear is that customers care more about function over form. Now, the humanoid embodiment offers a number of compelling advantages. You have bimanual manipulation, for example. So when you break down what's the value of a humanoid, it's not its ability to walk around, it's its ability to manipulate and dexterously apply skills to do complex tasks. And so Sanctuary for a long time is focused on hands. We've got very deep domain expertise there, and that's really the problem we're trying to solve, is dexterity for tasks that purpose-built systems can't do.
Mm-hmm. And our supporters for humanoid robots say, oh, once you train it, maybe it costs more to train it, build it, but once you build it, you can do multiple tasks, and maybe it has a better invest return. What's your opinion on that, Casper?
Yeah, I think, it is, I was talking about reliability. Really, we don't want helpers who are inexperienced workers. We want helpers who are experts at what they do, right? Like senior employees, not interns, right? So I think regardless of factor, it's really important the mastery of the task, right? So that we can trust that machine, this robot, to really complete this task, whether it's at home or at work, right? So I think we will be scaling by domains where the robots become really good at, right? And then these will be like, vectors of scaling, a lot of robots doing this in many different locations, and only then we'll go really broadly. So the broad capability is very appealing to us, but in reality, I think it's hard to achieve. And our approach to this is that we deploy robots at the customer sites, and we monitor and watch every action they take. We record videos, we record all of the data, and we analyze which were successful, which were not. And then the unsuccessful cases, we call it library of chaos, right? Those are most valuable, right? Like this really shows where the system is failing today, and then you go ahead and improve this, right? Like you improve this by training machine learning systems, or improve it by hardware improvements, or design of the grippers, whatever it is. And then in this loop, you can really get the system very good in some domain, right? And I don't think this is going to change in some way as we go to humanoids and more use cases. If you want to change tires in a car, which potentially is a good work for humanoid robot, right? We need to change tires in our cars, then you need to be good at this, right? Like, you need to be an expert at that function. And I think doing tasks at home does not really help you in that, right? Like, you need to train in that environment.
James, do you agree?
Sorry, what was the question?
Casper said, there are bottlenecks for humanoid robots and how to train them and those stuff. Yeah.
For sure. Like in all training these systems, you have to train on the task you're focused on. And what's really important is you've got the underlying infrastructure to improve when you see failure modes. And that loop is, as Casper pointed out, exactly what you've got to master. Like the dream is you can train this robot, expose it to an unseen task, and then zero shot it out of the box. It does it perfectly. That is a decade or two, maybe not even in our lifetime. You're always going to have to train on the specific task you're focused on. Just a comment on homes, because that would be amazing if we could get a helper in our house to help us out with this. But if you look at where the technology is, the unit economics, the safety, if you take in all these factors, where you would apply a humanoid, the last place you would go is the home, just because of the safety concerns, unit economics. You would actually go to the factory because the customer knows how to ingest and take on a sophisticated system like a robot because they've been doing it for the last 30 years.
And maybe on this, right? Like, there's always the economic force behind what we do, right? And our business activity. So when you look at the value of the robot at home, right? Like, okay, anyone can assign the value, how much we'll be willing to pay per month or per year for the robot to help us at home. But when you look at the, let's say, logistics, right? The average wage there is $20, $25 per hour. You know, we look at cases or tasks that are performed 3 shifts, so at least 2 shifts, but frequently 3 shifts, 6 days a week, and then sometimes some work on Sunday, and then, you know, if this is 2 shifts, then there are peak seasons, November, December, when they're, you know, from 2, 3 shifts. So the value of the robot performing this work is, let's say, you know, $150,000 a year, right? I don't think many people will pay $150,000 a year for a humanoid in their home. So I think these industrial environments where real work is happening is really where we'll see the uptake first, right? Because there's basically money to pay for it.
Yeah, they have the money. So it sounds like it's still a while till we can see robust caretakers at home on a large scale.
Unfortunately.
We hope for this, of course, right? Like, as we're getting older.
Yeah, to wrap up the conversation, well, we have a lot of hypes about robots these days. What's one thing you think people are overestimating about robots and one thing they are underestimating? I start with you, James.
On overestimating, I'm sure everyone's seen the fancy videos out there. That is after them trying to do that task 100 times and they catch it on video once. So I think people are definitely overestimating what they can do in the real world. And then us underestimating like the capabilities they are demonstrating, that will be a reality for sure. And it's just a question of timing.
Yes, I think, you know, when we talk to customers in logistics who are thinking about applying robotics into their warehouse, into their use cases, what really works is taking them for a visit to a reference site with another customer who's happy and has many robots deployed, right? So this is not visible a lot in the LinkedIn videos and YouTube and TikTok, right? Because these are robots closed in the warehouses, but a little dusty robot that's working and, you know, people treat it as a normal thing, that's really the sign of success. And I think, you know, that has accelerated our journey in a very significant way when we started deploying these robots, and then we could take prospects, new customers to existing sites to show them this works. And you know, one of our claims to fame is that we had 0 churn, so every robot that went to production is still there, and the first robot is there for almost 7 years. So I think that's what's beautiful about this, that the customers are addicted. Like, if there is this machine that does the work, nobody's going to kick it out from the warehouse.
Yeah, thank you. That brings our conversation to an end. Thank you so much for these insights, and I personally found it very helpful, and thank you all for joining us.
Thank you, Daisy.